Hello, this is Meet a Modeler. My name is Anthony Tedaldi, and I am a chemistry teacher at Belleville High School in Michigan. I teach using the modeling chemistry curriculum, and I attended a workshop in 2017, and that was through my teaching fellowship, Knowles Teacher Initiative. Today, I'd like to share with you an activity called a particle diagram check, and I could use this, and you could use this any and all the time. So, we have our model so far. I usually keep it on my whiteboard behind me. Students have it in their notebook. And as we do labs and demos, we are all taking notes on what do we know about our model of matter so far. But I want to keep track of students remembering how to draw matter each step of the way. So I have what's called a particle diagram check. And so I'll have this prompt and I'll say represent an object that's 5 grams per milliliters in 2 different ways. And I'll give them a bit of a time to do that. Now, I don't just throw the prompt with no resources or materials. They're allowed to use their model, but I also throw into Google Classroom a Google slide that has a nice little template. I provide the template, and it's just very quick for me to copy, paste, The template saves time, so you don't have students having to insert a shape or get frustrated with trying to draw a square a certain size. And it kind of makes answers a little bit easier to check uniformly. So they could choose what size box they want. They could choose how many particles they're going to draw. It kind of focuses on how they're going to represent density, not mass by itself, not volume by itself, but density. The great pro here over doing this just on paper or on a worksheet in the Google Classroom on a Google slide is by being able to see it live in real time on my screen in front of me using something called GoGuardian. Now, our school pays for GoGuardian, so if you do not have that, that's okay, and we could talk about that at another time. You could just simply look at it in an assignment in Google Classroom. And as you can see, I could see all of the students' responses live, and I could just click and see what they're doing. And I do this on purpose because it kind of saves me time from having to float around every 5 seconds. Maybe I'll float around once in a while if I see a student not doing work or not on task. But I could see all of the students' work in front of me, and I tell them I'm looking for about 5 or 6 student responses to share so we could discuss. And so some students kind of take that as a way of holding themselves accountable for doing work accurately or showing their best effort. I also kind of warn some students, I'm like, hey, can I use yours? Yours is great. Or hey, can I use yours, students? I love your mistake, right? And sometimes it kind of relinquishes the pressure of making mistakes by from oh, I love your mistake. I want to talk about it. And so then from all of the student work, I'll make a criteria, a point scale. If I was going to grade this on a quiz or a test or grade each other, here's what we would be looking for. And so students keep this in mind, and then we start looking at some student responses. And we go, oh, how many points would we give this? And we have a discussion as a whole class, or even it's just 1 or 2 people be 2 points, 1 point. I have them justify. This is great analysis skills, just having them looking at making a claim and backing it up with evidence, right? They have to say that I'm going to only give them 1 point and why. And so we look at other student responses, and I try and sequence them in a way that gets to an ideal response, or even just almost ideal for us to kind of move on forward, right? So oh, this would get 3 points. They have a key. They have consistent volumes. They have consistent masses. And then after all of that back and forth activity, just kind of getting students engaged here, I might have a little bit of notes or a summary about how we draw particle diagrams now, right? And maybe throwing in some vocabulary about more or less dense and how students drew their particle diagrams. Now, best times to use this, you could use this in the beginning or end of class, end of a unit for review, right? So we draw on tests or quizzes, so that's important there. Or before we start a unit, just making sure we remember. Before and after a lab or demo, just to have individual student accountability. If there's a question on a worksheet that students are struggling with, that'd be a great time to do it there too. Or if there's just a misconception that you anticipate or that you are seeing a lot of, you just have them draw it. So I want to thank you all for this time and allowing me to share an activity I do in my classroom, in my modeling chemistry classroom. If you have any questions or thoughts, you can email me at atedaldi@vanburenschools.net, or there is a Facebook group called Modeling Instruction in Chemistry. I am one of the moderators that actually created the group. So if you jump in there, there's constant conversations about sharing resources or just ideas to kind of get us going in the modeling chemistry classroom. Thank you so much.